Hello, welcome back. My name is Peter. This is Dev Suvara. Today's topic is performance analysis and optimization of your software. I love it. It's one of my favorite things. All the way back from when I first started development, it was one of the things that I actually really enjoyed doing, and I really enjoyed seeing the results because they're very clear and significant results that you see with that improvement and of performance. So what are we talking about here? So essentially, when you have a program that does something, it has a kind of like the speed at which it does things, right? So it's pretty common sense. And in some cases, when you find bottlenecks that are slowing down the performance of the program, you need to find that bottleneck and fix it. This was really true very much for video games. So there was a lot of work that went into optimizing things like rendering engines, memory management, all of this kind of stuff. And way back when we were working on the Game Boy and Game Boy Advance platforms, there wasn't any inspector tool. And if you look now, like just have a look here, you will see that the inspector tool for Xcode that you can performance analyze your iOS apps or Mac apps. Is like very, very complete, has so many features. You can dive into anything and you can measure anything. And it really is quite helpful in quickly identifying things that are slow. So way back in when we were working on the Game Boy Advance and Game Boy, we actually built our own memory management systems. We built our own, the kind of more fixed memory. And we also built our own performance analyzers. So what we would do is we'd have a debug version that would have like a little millisecond timer counter. We would have the clock, read the clock, and we would just get the amount of clocks that were executed per function. And so you could use that to try and isolate where the biggest costs were in your code. And so it wasn't really, once you built it, it wasn't really that difficult. Later on, when we got to other platforms like Xbox and the Nintendo 64, GameCube, like there were more tools that we could use that would help us with performance analysis and then optimization. Now, optimization generally, like you find the problem first, and then you look and try to understand what's going on, and then you find a solution. So the first thing that happens generally is you're writing stuff and you don't really think too much about optimizing it when you're starting. You're just trying to get it to work, which makes sense. It makes sense to try and optimize algorithms when you start building something, but it's not always the case. You want to build cool stuff, and you're in the process, and you've got the things functional, but they're just running a bit slow. And so what happens is you get to this point when you're like, okay, let's take this code, let's look at all of the things that are going on and find out what the slowest thing is that has the biggest impact on performance, the thing that needs to get fixed, run fast. And then there's two parts to it, right? You can fix the code to make it more optimal for the machine that you've built it on, and you can rework the algorithms, and you can rework the data structures. A good thing is like if you have some list of items that needs to be sorted, you can, pre-sort it before it goes in without having to sort it every time. Another item is like, the structure, the way that you structure your data sets. So one really cool optimization for Doom early on was the binary space partition, was a data structure that allowed this 2.5D world, if you know a little bit about it. Cool. If you don't, go and check out some videos about how Doom was built. Doom was a game back in the 90s. And then, there's things like memory management also. So, you want to optimize the positioning of things that are used most often, right? So there's like, you have caches, you have like, I think first read cache. The more you read, something kind of like comes up from the stack, so you don't have to go through a list. So basically you have a cache hit and you have an item in that cache that might be like a element down the chain. And so what you do is like every time you kind of retrieve that value, you kind of put it to the top so you don't have to step through. It works like you do that for hash maps a lot. And so all these little optimizations, when you get through the process, you'll find that, this rendering, this game loop was taking like, say, 1 second to complete with all of this stuff going on. And now it's like 1/10 of a second. And that is a really rewarding part of software development, especially game development. So Look, I thought I'd share the magic of performance analysis and optimization of code. Really enjoyed doing it. I mean, even in these days when I work on software applications for IoT, I still have run into performance issues with updates and data updates and state management, things like that. You don't really expect it, but you kind of lose track sometimes of what's going on with all of the data that's being pushed around. And I've had to, even for like a list view with updating state that updates the presentation layer or the view, was just happening way too often. And so you kind of figure out what you need to do. You do it, and then wow, cool, it works really fast, works really well. So with all that in mind, I hope see if you can find a project that you're working on, and have a look at your performance analysis tool and see what's slow, what can be improved, what can be made faster, and I hope you get as rewarded and eager to fix these things as I have been. So I think that's it for today. Thanks for tuning in. I'll see you at the next video next week. Catch ya.